ठीक है, छोड़ दे. Okay, chalo. So you know what is electric field now? You know what is electric field, and we have done electric field calculations for some shapes, some charge distributions. Okay, electric field for other kind of charge distributions, that is also something we need to learn. जैसे disk आएगा, and then spherical shell आएगा, and then what do you call it, solid sphere आएगा. All those kind of things we are going to do, but we are not going to do those lengthy derivations. What we are going to do is we are going to derive that using a relationship between field and potential, and that is very central to this chapter. It's a very important concept you have to learn in this chapter, and that is the relationship between electric field and potential. Okay, so before we understand potential, first what we need to understand is something known as potential energy. Alright, potential energy, and obviously you know what is potential energy. You have quite bit of idea what is potential energy, how it is calculated, how is it defined, and all those things. Okay, so what we are dealing with is electrostatic potential energy. Okay, so what do you know about potential energy? Just a small recap. What is potential energy? Potential, क्या बोला? Ability of body to do work. तो किस क्लास में है? हैं? किस क्लास में है? पास किया, 11 पास किया, 10 पास किया था, तो पास कर लिया है. Okay, there is nothing called potential energy. Establish that fact. There is nothing known as potential energy. What is there? It is the change in potential energy. Potential energy in itself has no meaning. There is change in potential energy. Okay, and change in potential energy depends on what? Or change in potential energy is simply the negative of work done by the internal conservative forces. So change in potential energy is defined for conservative forces. Okay, we write the change in potential energy as the negative of the work done by internal conservative forces. तो ये छोटा सा term यहाँ पे it is telling us a lot of things. First of all, you can only define a change in potential energy corresponding to a conservative force. ठीक है? That is why we studied gravitational potential energy. That is now we are studying electrostatic potential energy. That is why we are going to study magnetic potential energy and so on. Is that correct? It is only defined for internal conservative forces. दूसरा, you have a term here known as internal conservative forces. The force has to be from within the system, right? If the force has to be from within the system, it has to be a system at least. Okay, so we cannot define a change in potential energy for just one particle. We can define it for a system of particles. Is that correct? Okay, and here what are those particles? Those particles are charged particles, so that they have electrostatic force between them, and that electrostatic force between them is the internal conservative force, and the negative of work done by that force will be the change in potential energy. Is that correct? Okay, so here's a very simple derivation for electrostatic potential energy, and all we are going to assume is this. So there is a charge Q1 and there is a charge Q2. Initially, they are separated by a distance R1. Alright. Now what I'm going to do is, I'm going to move this charged particle by a certain distance. So what I'm going to doing is, I'm going to change the separation between the particles by some amount. Okay, so initially it was at R1, and I move it along a straight line, and now I have brought it to a distance R2. Okay, assuming both of them to be positive charges, what is the internal conservative force here? The electrostatic force. Assuming both to be positive charges, what is the direction of force on this particle? Very good. The force on this particle would be towards the right. And how much this force is going to be? It is going to be K Q1 Q2 upon R square. Okay, so now I have to calculate the work done by this particular force. This is the internal conservative force. Is that correct? Okay, so whenever we do work done calculation, first of all we have to understand, is it a constant force? Is it a variable force? Alright, if it is a constant force, F dot S is pretty much alright. But if it is a non-constant force, if it is changing with the position, can we use F dot S? No. What do we use instead? Very good, integral of F dot dr. Okay, and that is what we are going to use here, because the distance is changing between the particles. So the force between the particles is also changing. So we have to use integration here to find out the work done. Okay, so what do? We assume that at certain instant, this particle would have reached a distance r. And then from here, we are going to further displace by a distance tr. Okay. So for this very small displacement, I can assume the force to be constant. I can calculate the work done for this small displacement, and then I can integrate to find the displacement for the complete displacement. Is that correct? Okay. So first of all, what is the force over here? What is the force? What is the force on this particle? The force on this particle is, the separation between them is r. So the force between them is k q1 q2 upon r square. And then we are displacing it by the distance dr. What is the direction of force on the particle? Right. What is the direction of displacement? Right. So the work done would be positive. So what is the work done? The work done, the small amount of work done is k q1 q2 upon r square multiplied by dr. Is that correct? Okay. Now all we are going to do is, we are going to integrate this. And what would be the limits of integration? From r1 to r2. The limit of integration will go from r1 to r2. Alright. So what do I get? I get k q1 q2. That's a constant. dr by r square ka integral minus 1 by r. Minus 1 by r. So minus sign I can take it out. No problem. And then I have 1 by r, and the limits have to be from r1 to r2. Okay, so what do we get? We get the work done is equal to k q1 q2, and this would be 1 by r2 minus 1 by r1. Minus sign andar le jate hain, so this will become 1 by r1 minus 1 by r2. And that is the work done in this displacement. Is that correct? There was no work done on this particle because I assumed it to be stationary. Even though it had it experienced electrostatic force, but I assume it to be stationary, so no work done there. Okay, so this is the work done in moving a particle, two charged particles, changing the separation from r1 to r2. Is that correct? Okay. Secondly, I did not consider the path while calculating the work done. Okay, I could have moved it in any random fashion. I don't need to do that. Why? Because it's a conservative force, so it does not depend on the path. Is that clear? So this is the work done in moving, changing the distance from r1 to r2 between two charged particles. Is that correct? Okay. And that is how we define the change in potential energy, the work done by the internal conservative force. So I can also write it as the change in potential energy is k q1 q2 1 by r1 minus 1 by r2. Is that correct? Can I rub this part off? But what we are interested in is sort of defining absolute potential energy. Okay, and how do we do that? To define absolute potential energy, we have to choose a reference. Okay, we have to choose a reference. Okay, so what reference are we choosing? So here what are we doing? We are moving the particle from r1 separation to r2 separation. Okay, we are moving the particle from r1 separation to r2 separation. So what we assume is, we are bringing the particles from very far away. That is, the initial distance between the particles is very large. That means, what am I suggesting? I'm suggesting that r1 tends to infinity. Very large distance between them. Is that correct? Haan. Ruk ja. Okay, I'm taking it from, initially the particles I'm assuming are placed at a very large distance. So r1 I'm suggesting is tending to infinity. And then I'm bringing them to a separation r. Okay, so what am I suggesting? I'm suggesting that r2 should be equal to r. This is the initial separation. This is the final separation. So the final separation is r. Is that correct? Okay. And what I'm assuming is, I'm assuming that the potential energy at infinite separation is 0. That is my assumption. Is that correct? The potential energy at infinite separation is 0. That is my assumption. It's not necessary you believe in this. But whatever potential energy term we are calculating is based on this assumption. Is that correct? So all I'm going to do is, I'm going to substitute it here. So delta U, can I write it as UR2 minus UR1? potential energy at initial position, potential energy at the final position. This should be equal to k q1 q2 1 by r1 minus 1 by r2. Now what I'm going to do is I'm going to put the limit, substitute. I'm going to substitute this assumption in this formula. Okay. So u r1, the potential energy at r1, that means what? The potential energy at infinite separation. What have we assumed that to be? It's 0. Then what do? We substitute r1 ki jagah infinity. And what is r2 equal to? R2 is equal to r, the final separation. So what does this come out to be? R2 is r. So potential energy at r separation is given by minus k q1 q2 माइनस साइन कहीं तो गलती हुई है. Oh, exactly. हाँ, वही गलती हुई है. So change in potential energy is the negative of work done. So this was the work done. Yes, my mistake. Change of potential energy is the negative of work done. तो यहाँ एक माइनस साइन आएगा, यहाँ पे भी एक माइनस साइन आएगा, तो यहाँ पे finally this will come out to be this. Okay. The potential energy when two particles are separated by a distance r is k q1 q2 upon r. What is the underlying assumption? The underlying assumption that at infinite separation the potential energy you have assumed to be 0. If in a question tomorrow they say that no, that is not my reference level, so what you're going to do is you're not going to believe in this. But this is always going to be true. Clear? Okay, now let's talk about the sign. If both q1 and q2 are positive, what is the potential energy? Positive. If both q1 and q2 is negative, what is the potential energy? Positive. If q1 and q2 have different signs, what does negative potential energy mean? Yes, it's a bound system. Alright, and this kind of model you have already seen. Where you have seen this? Atomic structure, Bohr's model. Bohr's model mein whatever energy you calculate, that is the electricity. Exactly, this is exactly what that is. तुम लोग जो ये कैलकुलेट करते आ रहे हो बोर्स मॉडल में द एनर्जी, दिस इज इट, दिस इज एग्जैक्टली व्हाट दैट इज दैट करेक्ट? एग्जैक्टली दिस इज व्हाट दैट इज. ओके, सो देयर व्हाट हैपेंस, द पोटेंशियल एनर्जी कम्स आउट टू बी रादर द टोटल एनर्जी, बिकॉज वहां पे पार्टिकल्स का काइनेटिक एनर्जी भी है. द टोटल एनर्जी कम्स आउट टू बी नेगेटिव. व्हाट डज दैट सजेस्ट? इट्स अ बाउंड सिस्टम, दैट द फोर्स बिटवीन देम इज एन अट्रैक्टिव फोर्स. इफ बोथ द पार्टिकल्स आर पॉजिटिवली चार्ज्ड, the system is not a bound system. They'll try to separate out. Is that correct? Any problem? Okay, so this we are going to use very frequently. Potential energy for 2 point charges, ये भी ध्यान में रखना, not for any kind of charge distribution. Only for point charges, the potential energy at r distance would be k q1 q2 upon r. Is that correct? So suppose you have an equilateral triangle and 3 charged particles are kept at the vertices of an equilateral triangle. Okay, they have the side of the triangle is A. Okay, now what you do is, or let's say 2A, isko 2A मान लेते हैं. The side of the triangle is 2A. Now what you do is you move this particle slowly. You move these particles slowly. And now you keep them at a separation of A. Okay, so what is the natural tendency if I leave these particles like that? Would they come close or would they separate out? They'll separate out. Okay, so when they have been brought closer to each other, can it be done on its own? मतलब somebody would have done this. मतलब external work की जरूरत. Now I'm interested in finding that external work done. Is that correct? Okay, so what we have to do is we have to find the work done by the external force. Okay, then what we are going to do is we are going to go back to that concept. कौन सा concept? Work energy theorem. जब external work नहीं होता है, non-conservative नहीं होता है, then that is the work energy theorem reduces to energy conservation. Otherwise, what do we have to use? We have to use work energy theorem. Is that correct? Okay. So if I apply work energy theorem, what do I have? The work done by external force is equal to delta U plus delta K. There is no non-conservative force anyway. So the work done by the external force is equal to the change in potential energy plus the change in kinetic energy. Okay. So if you have listened carefully, what did I say? That these particles have been moved slowly. Moving slowly means bina change in kinetic energy. There is no acceleration given to the particles, so the change in kinetic energy is 0. So what do I have? I have that the work done by the external force is simply the change in its potential energy. Okay. So we need to find out the final potential energy, the initial potential energy, subtract that, and that will be the work done. Is that correct? Okay. So we know the result for potential energy of two particles. But what do we have here? We have three particles. Okay. So what we're going to do is to calculate potential energy of particles which are more in number, more than 2 in number, what we have to do is you have to calculate the potential energy piecewise. Piecewise matlab there would be a potential energy between these two. There will be potential energy between these two, and there will be potential energy between these two. Is that correct? Okay. If I'm not even talking about this particle, they have an interaction between them. Okay. Somebody would have brought them from infinity to that position. Usme kaam karna pada hoga. So they certainly, this pair has potential energy. Alright. And then what do we have? I would have brought this third particle also. So when I was bringing that third particle from infinity, this would have exerted a force. This would also have exerted the force. So anyone who is bringing that charged particle from infinity to this point would have done that resisting the forces of both of them. Is that correct? So iska aur iska bhi ek potential energy hai, iska aur iska bhi ek potential energy hai. Okay, so we have to find all possible combinations of two and find the potential energy. Okay, and what will be the potential energy of the system? The sum of all those potential energies. Okay, so how many terms would come in here? 3 terms. 1, 2, 3. So fortunately in this case all the terms are same because it's symmetric. Okay, so let's calculate that. So what is the potential energy? I'm calculating initial potential energy. So initial yeah. No, you'll have to calculate the total work done for the assembly. You'll have to calculate the total work done for the assembly. Matlab, there's only one particle here. Now you bring one particle. There's some work done. Then you bring the second particle. There's some work done. So to make this entire configuration, whatever is the work done, that will be the change in potential energy or the potential energy. Okay? Okay. So what am I interested in? The initial potential energy. What is the initial potential energy? K Q1 Q2 upon R. So this becomes K Q1 Q2 upon R. Sorry, R nahi hai, yahan pe 2A hai. Okay. For this combination, I'll have the same term for this combination, and I'll have the same combination for same term for this combination. So what is the initial potential energy? 3 times of this. Okay. What is the final potential energy? The final potential energy would be KQ square upon A for one combination, and we have 3 identical combinations, matlab into 3. So what is the change in potential energy, which is equal to the work done by the external force, that is UF minus UI, and that will become 3KQ square upon 2A. कौन सा? वो मतलब कौन सा पार्ट? UI calculate कैसे किया? देख. So there is one point charge. There is one point charge. What is the potential energy? K Q1 Q2 divided by the separation. So K Q into Q, KQ square divided by the separation between them. Point से मतलब? So that's what I'm doing. I'm calculating the potential energy of this combination plus the potential energy of this combination plus the potential energy of this combination. Okay, that is why for one combination I have this potential energy, but I have 3 identical combinations. So because of 3 identical combinations, I'm writing into 3. Here. So that will be the work done by the external force. Is that clear? Find the potential energy of the system. Okay, first of all, how many combinations can you see? 6 combinations. 4C2. 4 charge particles taken 2 at a time. How many combinations are possible? 4C2. अब उसमें देखो, हाँ थोड़ा मैथ मेरे को भी आता है. इतना सरप्राइज क्यों हो गया? उधर नहीं लगता है, उधर पीएनसी नहीं लगता है. हाँ 0 ही आ रहा है क्या? आई डोंट नो, हम तो अपने मन से डाल दिए. देखते हैं, हो जा रहा है तो अच्छी बात है. जीरो आ रहा है, बहुत खुशी की बात है. फिर okay. Combination 1, combination 2, combination 3 and हाँ आकृत का तेरा जाना चाहिए ना, तेरा ससुर तो इधर बैठा है. अच्छा इंतजाम किया है. I'm just going to write. Okay, for the first combination, it's KQ square by A. And how many such combinations do we have? 1 and 2. For this combination, this will be minus KQ square upon A. And how many such combinations do we have? 2. So this will become minus 2Q square upon A. Okay. Then what do we have? We have this combination and then we have this combination. So because of this combination, what is this distance? This distance is root 2a. Because of that combination, the potential energy would be kq square upon root 2a. And because of this combination, kaun sa? Ye wala. This will be minus kq square upon root 2a. So ultimately the potential energy of the system is 0. Clear? Alright. So that is how you are going to find potential energy of a system of particles. which are all point particles. If you have an extended object, the story would be different, and we'll talk about that later. Okay. Okay, now we get to the concept of, okay, write this definition also. Potential energy का एक definition भी लिख लो. Write the definition for potential energy. So obviously it's negative of work done by the internal conservative forces, but एक और चीज लिख लो. The work done, yeah, the work done, write down, the work done in bringing all the charges from infinite separation to a particular configuration, is the potential energy of that configuration. Potential energy of that configuration. ठीक है. सो ये डेफिनेशन तुम लोग बचपन से पढ़ते आ रहे हो, करेक्ट? ये डेफिनेशन बचपन से पढ़ते आ रहे हो. बट नाउ डज इट मेक सेंस? पहले तो समझ में नहीं आता होगा ऑब्वियसली. नाउ डज इट मेक सेंस? ठीक है, बिकॉज इट इज द नेगेटिव ऑफ वर्क डन. और एक चीज उसमें ऐड नहीं किया, स्लोली. Bringing to that configuration slowly. Slowly is a very important term. If it were not brought slowly, then the work done by external force would not be equal to the change in potential energy. Is that correct? Okay. Next we go to the concept of potential. Okay. We did not talk about potential. We have not yet talked about potential. We have not done gravitation. Okay, so once I do electrostatics, I don't need to do gravitation. That is, मतलब एक साथ हम लोग 2 चैप्टर खत्म कर देंगे. Okay, what do you understand by potential? Ability. सही बात है. Potential कुछ ना कुछ ability है. क्या है पता नहीं. But potential means कुछ ना कुछ ability है. Okay, okay. बचपन से ये सुनते आ रहे होगे ना? हाँ? Ability to do work, हाँ, similar lines, yes. लेकिन बचपन से हमेशा सुनते आ रहे हो ना, anything flows from or anything goes from higher potential to a lower potential. Anything, or for that matter, जब current की बात करते हैं, current electricity की बात करते हैं, see, वो always say this thing, that the current flows from higher potential to lower potential. Why? Energy कम करना चाहता है. So how does that happen? If it goes from higher potential to lower potential, what happens? क्यों कम हो जाता है? हाँ, तुम लोगों को पता है. Okay, so first you have to understand the relationship between field and potential. Okay, first of all, who is responsible for forcing? The electrostatic force in this case? Okay, where, how would the particle move? Who is responsible for that? Electric force. Okay, and you'll see that the relationship between electric field and potential is such that field is always in the direction of dropping potential. Okay, so पहले हम लोग क्या करते हैं? Let's define potential, then I'll try to explain that. First, let's just define potential. Okay, so what is the potential? Potential is very simple. So again, there is nothing known as potential. There is only something known as change in potential, and the change in potential is defined as the change in potential energy per unit charge. Alright, the change in potential energy per unit charge. But what we are talking about is, there is, let's say, a charged particle Q. Now all around it, the space it has exerted its field. The field is everywhere. Okay, but not all points are going to behave in the same manner. Matlab, if I place a charged particle, if I bring in a test charge at this position, its behavior would be a little different. When I place the particle at this position, bringing the particle at this position, its behavior would be different from this position. Why? Because all of them have different potential, and we'll talk extensively about what that means. But what I'm trying to make you understand is, one charge particle, let's say a combination of charge particles, it has exerted its force everywhere, its field everywhere. But different points have different potential. Okay, so how do we measure potential? We measure potential by calculating the change in potential energy per unit test charge. Matlab, what you have done is, this is point number 1 and this is point number 2. Okay, this is only one charge over here. You want to calculate the change in potential from this point to this point. Matlab, you are moving from this point to this point and you want to calculate what is the change in potential. How would you do that? First thing you're going to do is, you're going to bring in the test charge. And yes, pata hai test charge should be small, it does not affect the charge configuration, we know that. Okay, so what do we do is, we bring in the test charge. We place it here. And what do we calculate? We calculate the initial potential energy. Then we move this particle to this point. And then again what do? We calculate the final potential energy. And hence we have the change in potential energy. Okay, that change in potential energy is the potential energy between this system of particles. Okay, divided by the test charge is going to give me the potential. Okay, so you bring in a test charge, put it at position 1, find the potential energy. You take the test charge, put it at position 2, find the potential energy. The change in potential energy divided by this test charge is going to give you the change in potential. Analogous to force and electric field नहीं हुआ. हाँ, उस सेंस में एनालॉजी लेना चाहते हो तो ठीक है. हाँ, यूर सेइंग इज इलेक्ट्रिक फील्ड इज इक्वल टू फोर्स अपॉन टेस्ट चार्ज. हाँ, उस मामले में यू मे से इट इज एनालॉगस. यू आर राइट, उस मामले में ठीक है. बट रिलेशनशिप इज वेरी डिफरेंट. इज दैट करेक्ट? दैट इज हाउ वी डिफाइन पोटेंशियल, और रादर द चेंज इन पोटेंशियल. ओके, नाउ व्हाट वी वांट टू डू इज, पहले हम लोग क्या करते हैं, कैलकुलेशन वाला पार्ट कर ही देते हैं. ओके, सो व्हाट एम आई इंटरेस्टेड इन? I want to calculate the potential due to a point charge. What am I interested in? I want to find out the potential due to a point charge. Okay, and I'm directly calculating the potential. Why? Because for change in potential also my reference level is the same. I'm not using a lot of brain. जो मेरा पोटेंशियल एनर्जी का रेफरेंस, वही मेरा पोटेंशियल का भी रेफरेंस. ओके, व्हाट दैट मींस इज वी आर माइनस वी इंफिनिटी. वी आर ब्रिंगिंग द पार्टिकल्स फ्रॉम इंफिनिटी टू अ कॉन्फ़िगरेशन आर. दैट इज द सेम एज यू आर माइनस यू इंफिनिटी. आई एम यूजिंग द सेम रेफरेंस लेवल. डिवाइडेड बाय व्हाट? डिवाइडेड बाय द टेस्ट चार्ज Q. Is that correct? So what that means is a charge particle Q, and there is another charge particle small q which is at infinity, and I am bringing this charge particle Q at a position R. This is what I am doing. So the potential at R minus the potential at infinity is equal to the potential energy at R minus the potential energy at infinity divided by the test charge. Is that correct? मेरे reference के हिसाब से this is 0 and this is also 0. So this gives me VR is equal to, what is UR? The potential energy would be KQ into Q divided by R. That is the potential energy, and that I have to divide by the test charge. Kar diya divide. So what do I have? I have the potential at a point R, at a distance R, from a point charge is given by KQ upon R. Clear? Can I rub this off? Okay, now let's get to the concept. What is the relationship between field and potential? That is very important concept in this chapter. पोटेंशियल को डिफरेंशिएट करने से फील्ड नहीं आता है, उसका कंपोनेंट आता है. दैट्स एग्जैक्टली व्हाट वी आर टॉकिंग अबाउट. ठीक है. सो यू हैव अ चार्ज पार्टिकल Q. यहां पे एक टेस्ट चार्ज रख दिया है Q. ओके, द सेपरेशन बिटवीन देम इज R. ओके, सो व्हाट वी आर डूइंग इज let's say the field at this point is E. Let's say the field at this point is E. So what is the force on this charged particle? The force on this charged particle is QE. Now what I'm doing is I'm displacing it by a distance, small distance dr. I'm displacing it by a small distance dr. Okay, I'm using vectors because this displacement can take place in any direction. Correct? I'm using vectors because this displacement dr, though I'm showing it in a straight line, this could happen in any direction, does not matter. Okay, so the force is QE, the displacement is dr. So what is the work done by the internal conservative force, meaning the work done by the electrostatic field? What is that? That is F dot dr, and can I write that as QE dot dr? Can I write that? Okay, so that is the small work done. Now what is work done by the internal conservative force? That is the negative of change in potential energy. So can I write it like this? That is the negative of the change in potential energy, and that is equal to QE dot dr. Okay? Now what I'm going to do is I'm going to bring this Q down, and this I'm going to send this side. Can I write it like this? All this has been is being derived with the relationship between simply the change in potential is equal to the negative of work done by the internal conservative force. उसी से सारा कुछ ये derive कर रहे हैं. Now does this term look familiar? What is that? dV. That is the change in potential energy per unit test charge. So what is that? That is dV. So that is the change in potential, and that is equal to minus E dot dr. ठीक है? Now what I want to do is, इसका दो एस्पेक्ट है, दोनों डिस्कस करेंगे, बट पहले ये वाला कर लेते हैं. So can I write dV is equal to minus E dr cos theta? Theta is the angle between the field and the displacement. Okay, from here can I write E cos theta is equal to minus dV by dr. E cos theta is equal to minus dV by dr. Okay, so this relationship has come from where? First of all, work energy theorem and the definition of potential, that the change in potential is equal to the change in potential energy per unit charge. Okay, so what is E cos theta? Minus dV by dr, and both of them are very important terms which we need to discuss. So suppose this is the direction of electric field and the displacement takes place in this direction and the angle between them is theta. Okay, so due to any charge configuration, the field could be in any direction. Okay, but I am displacing, or the displacement is in a particular direction, that makes an angle theta. Okay, first of all, what is E cos theta? Very good. What is E cos theta? E cos theta is component of field in the direction of displacement. Absolutely. Component of electric field in the direction of displacement, and that is equal to what? Minus dV by dr. Now can you tell me what is minus dV by dr? Not just change in potential. Change in potential is dV. Yes, that is the rate of change in potential. ये minus sign को भी भूल जाओ. What is dV by dr? dV by dr is the rate of change in potential. And when I'm putting a minus sign, I specifically mean the drop in the rate. Alright? So E cos theta is equal to minus dV by dr. So minus dV by dr is what? Is the rate of drop in potential. मतलब per unit displacement कितना potential में drop हो रहा है. Is that correct? Per unit displacement, what is the drop in the potential? So minus dV by dr is the rate of potential drop. Okay, there are two very important things that we understand. Alright, there are two very important things we have to understand. First of all, I need to find out what is the field in this direction? Probably there are charges in this room. They have a certain configuration. They have electric field. They have electric field lines. Okay. What I'm interested in is कैसा field है मेरे को मतलब नहीं. मेरे को सिर्फ इस direction से मतलब है. All I am concerned about is what is this direction. How do I do that? What is the field in this direction? What do? I come here. E cos theta is equal to minus dv by dr. मतलब no matter where the field is, what is the exact value of the field? I don't know. But I'm only interested in the field in this direction. Okay. So what do? That component of field in this direction is equal to the rate of dropping potential. So what I can do is, I can stand here. I can calculate the potential right here. Okay, I know how to calculate potential. I can calculate the potential right here. Then I'm going to move in this distance. I'll move by a certain displacement, and then I'll calculate the potential right here. And then I'll calculate the drop in potential, and I'll also calculate the rate of drop in potential. Is that correct? And that will be the component of field in this particular direction. You get that? What do I have to do? I have to find the field in this direction. Only this direction. Okay, so what do I have to do? I have to walk along that direction, and I have to find the rate of drop in potential. Rate of drop. मतलब 1 मीटर जाने में यहाँ पे 2 वोल्ट था, वहां गए 1 वोल्ट हो गया. And this took me 1 meter. Okay, so what is the drop in potential? 1 meter. What is the drop in potential? 1 volt per meter. Is that correct? That I have to do. Okay, this tells us two things. First of all, this will tell me what is the direction of the field. Field ऐसा भी हो सकता है, field ऐसा भी हो सकता है. This is going to tell me the direction of field. How? सोचो. If there is field in this direction, then the component of field in this direction has to be positive. है कि नहीं? हम लोग क्या करते हैं? Any vector, let's say this is the vector, if it has a component in this direction, so this component has to come out what? Positive. So if there is field in this direction, that component of the field has to come out positive. Okay, so E cos theta should be what? Positive. If there is a component of field in this direction, E cos theta should definitely come out to be positive. Okay, if E cos theta comes out to be positive, minus dv by dr should also come out to be positive. Okay, यहां पे माइनस साइन ऑलरेडी लगा हुआ है. dv को फिर क्या होना पड़ेगा? नेगेटिव. आई एम सेइंग दैट अगेन. इफ देयर इज फील्ड इन दिस डायरेक्शन, there is a component of field in this particular direction, then this has to be positive. E cos theta has to be positive. If E cos theta has to be positive, minus dv by dr has to be positive. If this is negative, then dv has to be negative. What does that tell me? If there is field in this direction and I'm walking in that direction of the field, alright, I'm walking in the direction of the field, what is happening to the potential? It's dropping. Is that correct? So write this statement down. Field is in the direction of dropping potential. Field is in the direction of dropping potential. Alright, field is always in the direction of dropping potential. Alright, so if I go from here to here and I see that there is a drop in potential, that means what is the direction of field? The same direction I've walked in. If from going from here to there, मतलब from there to here, ठीक है, if I'm walking along this line and I see that there is an increase in potential, then what is the direction of field? The direction of field is that way. Is that correct? Okay. So now this solves us the mystery of why does everything go from a higher potential to lower potential. Okay, why does it go in the direction of higher potential to lower potential? Because field is in the direction of higher potential to lower potential. Is that correct? From here we can see that the field is always in the direction of dropping potential. Okay, so if something is set out naturally, उसको छोड़ दिया तू जा, alright, तो जिधर force लग रहा है उधर ही जाएगा ना, alright, जिधर force लग रहा है उधर ही जाएगा. Okay, so you take someone, no, not someone, you take something, go to the roof and drop it. इसीलिए I said something. ठीक है, you can do otherwise, but ठीक है. हाँ, कर नहीं पाएगा. हाँ, कहाँ? अच्छा ये क्या पैराशूट किधर है तेरा? लंबा कहानी क्या? मत सुनाना. Listen. Okay, so you drop it. What direction will it go? जिधर force है उधर ही जाएगा ना. Where is the force? The gravitational force is downwards, so it will go down. क्या? तेरा कुछ अलग दिमाग में चल रहा है क्या, किसको फेंकना है? Okay, so it will go down. Is that correct? Okay. So what is happening? And you know that high, जितना ज़्यादा height होगा, उतना ज़्यादा potential होगा. Okay, so what happens to its height? Its height is decreasing. So what is happening? The potential is decreasing. Why is the potential decreasing? Because as per the definition, the potential, the field is in the direction of dropping potential. Alright, if you set out something on its own, it will go along the direction of the field, or it will go in the direction of the force, and if it goes in the direction of the force, it is going in the direction of field, and that means the potential will drop. ठीक है? So what do we do in a battery? मतलब ये मान लो तुम्हारा कंडक्टर है, मान लो ये तुम्हारा कंडक्टर है. What do we do? You connect a battery. What is the job of the battery? The job of the battery is to maintain a constant potential difference between them. Is that correct? Too much bass. इन लोग को भक्ति गाना नहीं बनाना चाहिए क्या? क्या बजा रहे हैं लोग? मॉडर्न भक्ति. All right. So what is the job of this device? We'll talk about batteries in detail, but what is its job? To maintain a constant potential difference. Matlab, this is kept as at a positive potential, this is kept at a negative potential. So this is the direction of the dropping potential. तो इसका मतलब क्या है कि the field created inside is in this direction. That is the direction of the field created. Okay. So basically, what is the flow of what is current electricity? Is the flow of charged particles. How would charged particles flow? Is there someone to push them? And who is there to push them? They are charged particles. उन पे force कौन लगाएगा? There would be some electric field. Okay, तो इसका job क्या है? To create an electric field. And how does it create an electric field? Like this. Is that correct? So if electrons की बात अभी नहीं करते हैं, ठीक है, हमेशा हम लोग क्या बोलते हैं? Charge flows from higher potential to lower potential. Positive charge specifically. तो मान लो यहाँ पे charge particles है मेरे पास positive. मान लेते हैं अभी के लिए. किसका किसका नाचने का मन कर रहा है? ब्रेक है 5 मिनट का, नाच के आ. I can feel Doppler effect. That's better. They're going. Okay. So that is the direction of the electric field. So if I have put charged particles here, what will be the direction of the force? This will be the direction of the force. So how would they move? They move in this direction, and that is from the higher potential to the lower potential. Is that correct? बताएंगे, वो भी बताएंगे, वो भी बताएंगे. Does not matter. It is not going to matter. ठीक है, I'll tell you about that. Okay, another thing you need to understand is, and you can write this statement also. The electric field is in the direction. The electric field is in the direction. The electric field is in the direction in which the rate of drop in potential is maximum. The electric field is in the direction in which the rate of potential drop is maximum. Rate of potential drop is maximum. ठीक है. Okay, so we अभी समझ में आ गया कि if there is field in this direction, इस direction में जाएंगे तो there will be a drop in potential. Okay, but that is only telling me the component of field in this direction. But if I want to find out where exactly is the field, how can I do that? ठीक है, I can do that by understanding this, that the rate of drop in potential, नहीं sorry, the field is in the direction in which the rate of potential drop is maximum. Okay. So if I move along this direction, and this angle is theta, if I'm moving along this direction, what is the field I'm encountering? E cos theta. That is field I'm encountering. Okay. What if I change the direction a bit? Okay, I start moving slightly this side. What I'm going to experience? A stronger field. A stronger field. Okay. When am I going to encounter the strongest field? When you start moving along this direction. Alright, when you start moving along this direction. Okay, so what does that mean? If the rate of drop in potential has to be maximum, उल्टा बात करते हैं. If minus dV by dr is maximum in a particular direction, that means what? E cos theta would be maximum in that direction. I'm saying that again. Assuming minus dV by dr, that is the rate of potential drop. I'm walking in many directions, but in a particular direction I see that the rate of potential drop is maximum. Okay, what does that tell me? That if the rate of potential drop is maximum, E cos theta has to be maximum. When will E cos theta be maximum? When it is E. When cos theta is 1, and that means theta is equal to what? 0 degree. What is that? Ab ulta socho. So if you are walking along the direction of the field, this would be maximum. E cos theta would be maximum. That will be equal to E. Okay? And that would be equal to the rate of potential drop. Is that correct? So if this is maximum, this is also maximum. So what is the direction? What is specifically the direction of field? It is in the direction of in which the drop in potential is, the rate of drop in potential is maximum. Is that clear? ठीक है, इसका application हम लोग और देखेंगे, but these two concepts are extremely important. ठीक है, इसका अगर तुम लोग देखना चाहते हो rate of potential drop, gravitation तुम लोग नहीं पढ़े हो ना अभी? नहीं पढ़े हो. ठीक है, we can do this. तो ग्रेविटेशन में क्या करते हैं ना, ग्रेविटेशन में वी डिफाइन पोटेंशियल ऐसे, जैसे इसमें हम लोग कैसे डिफाइन करते हैं, डेल्टा वी इज इक्वल टू, या सिंपली वी इज इक्वल टू यू बाई क्यू करते हैं. ग्रेविटेशन में व्हाट वी डू इज पोटेंशियल इज यू बाई एम. ग्रेविटेशन में व्हाट वी यूज v इज इक्वल टू u बाई m, मतलब पोटेंशियल एनर्जी पर यूनिट मास. ओके, एंड वी आर टॉकिंग अबाउट द डिस्टेंसेस विच आर वेरी क्लोज टू द सर्फेस. अब इतना तो पता ही है, if the distances are very close to the surface, what is the potential energy? mgh. So what will be the potential? The potential would be gh. Is that correct? Okay, suppose this is height h. This is height h. मतलब this is height 0, this is height h. तो इसका पोटेंशियल क्या है? 0, और इस हाइट का पोटेंशियल क्या होगा? gh. Okay. Now what I can do is, I can set you, I have different slides. ठीक है, स्लाइड्स का अलग अलग स्लोप हो सकता है. ठीक है, I set you from here, you come along this direction. I set you from here, you come along this direction. Okay, or I can set you from here and you directly go down. इसमें चोट लगेगी, but ठीक है. Okay, I can send you in lots of directions. Okay, I want to find out in which direction is there the maximum drop in potential. ठीक है, I want to find out in which direction is there is maximum drop in potential. Okay, उससे पहले हम लोग क्या करते हैं, component वाली भी बात करते हैं. So what I do is I send you at an angle theta. Vertical से I send you at an angle theta. Okay, what am I interested in? I'm interested in finding the drop in potential, the rate of drop in potential in going from here to here along this direction. Okay, what is the rate of drop in potential? मतलब what is minus dV by dr? What is minus dV by dr? यहां से देखो, यहां से यहां जाने में what is dV? यहां का पोटेंशियल क्या है? 0. यहां का पोटेंशियल क्या है? gh. So 0 minus gh is minus gh. यहां पे माइनस हट के क्या बन जाएगा? gh. Okay, and that I have to divide it by dr. What is dr? Dr is this displacement. So if this height is h, what is dr? h by cos theta. That is h by cos theta. तो यहां से क्या मिलता है? यहां से we get g cos theta. ठीक है, अब सोचो तो, what does that tell me? That the direction of field, मतलब the component of field in this direction is g cos theta. मेरे को कैसे मिला? By calculating the rate of drop in potential. Correct? Do we know this already? Obviously no. What is g? G acts downwards. G acts downwards. What is the component of g in this direction? The component of g in this direction is g cos theta. So that matches exactly. ठीक है, the rate of drop in potential along this direction यहां से कैलकुलेट किए, and what is that equal to? The component of field in the direction of displacement. Clear? Okay, now what do I need to find out? I need to find out, I'm going through various directions, but I want to find out in which direction should I go so that the rate of drop in potential is maximum. How would I find that out? The rate of potential drop is maximum. The change in potential is the same from here to here, here to here, here to here. I'm going from this level to this level. What is the change in potential? The same. When will be the rate maximum? When the displacement is smallest. When will the displacement be smallest? You come down straight away. So if the distance is smallest, this is the direction in which the rate of dropping potential is maximum. Isn't that the direction of the field also? We know that. Is that clear? Okay, so that concept is, I hope that is clear to you, and then let's get back to this equation. Okay, so there are two things we might have to do. क्या हो सकता है अपने को? मेरे को field दिया रहेगा, and I have to find the potential in going from one point to the other. Okay, I have been given the field. I want to find out the potential. Okay, so what we are going to use is, we are going to use this dv is equal to minus E dot dr. Then what we are going to do is, we are going to integrate on both sides. So dv मतलब क्या हो जाएगा? dv will become the change in potential. Integrating all the small changes will get the change in potential, and that change in potential would be equal to what? Negative of E dot dr. But this integration you always have to do from the initial position to the final position. मतलब if you know the field, that is how you are going to find out the change in potential. Change in potential मतलब एक position से दूसरे position जाने में क्या change आया. So for that you have to integrate this quantity from the initial position to the final position. That is one aspect. Okay, what could be the other aspect? The other aspect would be, and इसका I'll show you few examples. या पहले यही दिखा देते हैं. चलो, write down the question. Write down the question. The question is, the field is 50 Newton per Coulomb. Field का unit Newton per Coulomb भी होता है, volt per meter भी होता है. So the direction of field is 50 Newton per Coulomb in the upward direction. Field is 50 Newton per Coulomb in the upward direction. Calculate the change in potential in descending 10 centimeter vertically. Is the question clear? Okay, so what is the question? The field is in the upward direction, 50 Newton. Okay, what do we have to calculate? If I am descending by, कितना बोला मैंने? 10 centimeter, descending by 10 centimeter in the vertically downward direction, what will be the change in potential? ठीक? That's what we need to find out. We are going to use this, even though ये बहुत simple है, but we are going to use this proper thing. So you are here. Now you go here. What is the direction of the field? The direction of field is like this. This is the initial position and this is the final position. Okay, so how do you integrate? You have to go to a distance r. You have to go to a distance r. Then you will go a further distance dr and you find the change in potential. Integrate that to find out the final potential. Okay, so what am I going to do? I'm going to do this. dv is equal to minus E dot dr. dv is equal to minus E dot dr. So dv is equal to minus E is upwards, dr is downwards. So what will be the dot product? Minus E dr. E dot dr. E ऊपर है, dr नीचे है. So this dot product will become minus E dr. मतलब dv will become E dr. Is that correct? बहुत सारा है, पीरियोडिकली आ रहा है. कर सकता है क्या ईशान? भगाना है उनको. Alright, listen up. So we integrate dv, what do we get? Delta v. This you could understand. R is varying from where? From 0 to small r. E. What is this E? Constant. क्या होगा? बाहर आ जाएगा. And dr का इंटीग्रल क्या हो जाएगा? R. So what is the change in potential? dr. And this is a result we are going to remember. This is a result we are going to remember क्योंकि बहुत frequently use होगा. ठीक है? Why could I take this E out? Because it was constant. So this result is only valid when E is constant. This result is only valid when E is constant. ठीक है? अब simple है. Potential difference क्या होगा? E multiplied by the length जैसे जा रहे हो. Okay, but you have to be careful with what? With the sign of E. And that is very easy to understand. Why? Because field is in the direction of dropping potential. Okay. So you are going from here to here, you are descending. Are you going in the direction of field or opposite to the direction of field? Opposite to the direction of field. So V should come out to be positive or negative? Positive. Positive, na? You are going opposite to the direction of field. So the potential change will come out to be positive. कितना होगा? E into L. What is E? 50. What is L? 0.5. तो 5 volt होगा. Right? But I know that I am going opposite to the direction of field. So change in potential क्या होगा? This will come out to be positive. Is that clear? Any problem? Okay. इसमें अब क्या करो? Now you do this. Okay, now you do this. Now it is descending not along the vertical downward direction but at an angle theta. It is descending at an angle theta. Now you tell me what will be the change in potential. Descending at an angle theta. Downwards, but at an angle theta with the vertical. Electric field ऊपर ही है. ER cos theta. ER by cos theta. किसी का कोई और आंसर भी है? हम्म। सोच क्या रहे हो भाई, कलम चलाओ ना. यू नो हाउ टू इंटीग्रेट. इंटीग्रेट एंड फाइंड आउट. इंटीग्रेट एंड फाइंड आउट. आर डी आर डिस्प्लेसमेंट हो गया. माइनस सी आर. माइनस तो नहीं होना चाहिए, सिर्फ ई आर आएगा. तो दोनों में फर्क क्या पड़ा? चेंज इन पोटेंशियल उतना ही रहेगा. क्यों उतना ही रहेगा? तो नॉट एग्जैक्टली. रेट ऑफ पोटेंशियल ड्रॉप डिफरेंट रहेगा. क्यों? वही तो पूछ रहे हैं, वही मेरा क्वेश्चन है. वाई? यू आर करेक्ट. नो, इनिशियल फाइनल पोजीशन इज नॉट सेम. ये यहां से यहां है, ये यहां से यहां आया है. व्हाट डिस्टेंस सेम? कहां डिस्टेंस सेम है? अरे क्या बोल रहे हो? दिख नहीं रहा है. ये स्केल लाके दिखाए क्या? हाँ सही बोल रहा है. तो एक तरह से सही बोल रहा है, और अच्छे तरह से बोल. यू आर एब्सोल्युटली राइट. चेंज इन पोटेंशियल ई आर ही होगा. एंड इंटीग्रेट करके देख लो. इतना टाइम तुम लोग क्यों लगा? एटलीस्ट इंटीग्रेट करके तो निकाल लेना चाहिए ना. आर डिस्टेंस पे, आर नहीं, ये आर है ना, तो एल क्या के लिए एक्स ले लेते हैं. एक्स डिस्टेंस पे यू गो डी एक्स फर्दर. ओके, व्हाट इज द डायरेक्शन ऑफ द फील्ड? अप. व्हाट इज दिस डायरेक्शन? ऐसा. व्हाट इज द एंगल बिटवीन फील्ड एंड द डिस्प्लेसमेंट? हाँ, पाई प्लस थीटा, पाई माइनस थीटा एक ही बात है. पाई माइनस थीटा, दो वेक्टर के बीच में, विल टेक द स्मॉलर एंगल. सो ई ऐसा है एंड डिस्प्लेसमेंट ऐसा है. व्हाट इज द एंगल बिटवीन देम? द एंगल बिटवीन देम इज पाई माइनस थीटा. करेक्ट. सो व्हाट इज dv? dv इज इक्वल टू माइनस ई डी आर into cos of pi minus theta. What is cos of pi minus theta? Minus cos theta. So dv is equal to minus e dr cos theta. Sorry, e ये चला जाएगा. dv is equal to e dr cos theta. Is that correct? So if we integrate this, delta v will come out to be, e is a constant, cos theta is a constant, correct? E cos theta comes out, and this will be the integral of dr. Integral of dr क्या होगा? dr मतलब r मतलब x मान लो. I am choosing x. So what is the integral of dx? Integral of dx. Yeah, this is the distance. This is dx. What distance is this? R by cos theta. This distance is r by cos theta. So the integral of ds is r by cos theta. So this comes out to be e cos theta multiplied by r by cos theta. तो क्या बचा finally? er. तो वही आना था, उतना मेहनत क्यों किए? अरे क्या बोला है? नहीं, एग्जाम सही बोला है. कैसे आया तेरे दिमाग में? ऐसा आकाशवाणी हुआ उधर से. स्पिरिचुअल एनर्जी आ रही है तेरे में. You're absolutely right. You're absolutely right. You're absolutely right. ठीक है? Let's see that. E cos theta is equal to minus dv by dr. E cos theta is equal to minus dv by dr. If I move along theta equal to 90 degree, this is E. I am moving along dr. What is E cos theta? 0. Then what is this? 0 हो जाएगा ना. dv by dr की बात कर रहे हैं. E cos theta, if I am moving perpendicular to the field, the component of in that direction is 0. If this is 0, what is the rate of drop in potential? 0. If this is 0, what is V? A constant. आई बात समझ में? मतलब if you are moving perpendicular to the field, what happens to the potential? Does not change. If along a surface you are moving and the potential does not change, मतलब the potential is same on the entire surface, and we call those equipotential surfaces, and that's a very important result. Write this down. कैसे आया तेरे दिमाग में? Very good. चल, जैसे भी आया. Okay, write this down. अब इंटेंसिटी भी बढ़ा दिया है. और आइडियाज आ रहे हैं. अपने से लिख लोगे? Okay, write this down. Equipotential surfaces are perpendicular to the electric field. Equipotential surfaces are perpendicular to the field, and that is due to this reason. If you move perpendicular to the field, the component would be 0, hence the drop would be 0, hence V would be constant. Is that clear? So what is that telling us? Only the displacement along the direction of the field is going to have any effect on the potential. Alright? Any displacement which is perpendicular to the direction of field is not going to have any effect. Matlab this displacement, can I say, is equal to this displacement plus this displacement. This displacement is a vector summation of this displacement plus this displacement. So this displacement is along the direction of field, or opposite to it. It will have an effect on the potential. But this displacement is perpendicular to the field. It is not going to have any effect on the potential. Is that clear? ठीक है, एक और क्वेश्चन लिखो. Infinitely long linear charge distribution. Infinitely long linear charge distribution, lambda, charge density lambda, is placed along the z axis. Is placed along the z axis. Is placed along the z axis. Find the change in potential. Find the change in potential in going from r comma 0 comma 0, in going from r comma 0 comma 0 to 2r comma r comma 0. मैं क्या बोला? r comma 0 बोला क्या? r 0 0 in going from r 0 0 to 2r r 0. हाँ, 2r r 0. क्या बोल रहा है? हाँ तो क्या 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 क्या? सोच नहीं, दैट्स नॉट करेक्ट. सोच एक बार. फील्ड के डायरेक्शन से सोचेगा ना कि थ्रेड के डायरेक्शन से सोचेगा? What did I say? R comma 0 से नहीं ये करने में ना, ये करने के लिए रुक जाओ. ये करने में ये मेरे को बताना पड़ेगा, अभी नहीं कर पाओगे. रुको, लेट मी मॉडिफाई द क्वेश्चन. हाँ, k लैम्डा बाई r नहीं 2k लैम्डा बाई r होता है भैया. लीनियर इन्फिनिटली लॉन्ग लीनियर चार्ज डिस्ट्रीब्यूशन 2k लैम्डा बाई r होता है. 2k लैम्डा बाई r होता है. दिस यू विल नॉट बी एबल टू डू बिकॉज दोनों डायरेक्शन में ex ey दोनों लेना पड़ेगा. रुक जाओ, लेट मेक इट सिंपल. हाँ क्या नहीं होगा? 0. वेट. ठीक है. सो व्हाट डिड आई से r कॉमा 0 ना, उसको r कॉमा 0 टू 2r कॉमा 0 बस इतना करो. r कॉमा 0 टू 2r कॉमा 0 अभी इतना ही करो. माइनस के लैम्डा बाई आर. माइनस नहीं आना चाहिए. और वैसा नहीं आएगा, k लैम्डा बाई आर नहीं आएगा। हाँ, माइनस के लैम्डा बस। नहीं, पहली बात माइनस नहीं आना चाहिए। बताओ क्यों माइनस नहीं आना चाहिए? इट इज मूविंग अलोंग द डायरेक्शन ऑफ फील्ड। सॉरी, इट इज मूविंग, हाँ तो माइनस आना चाहिए, सॉरी नहीं मेरी गलती। इट इज मूविंग अलोंग द डायरेक्शन ऑफ फील्ड, तो पोटेंशियल नेगेटिव आना चाहिए। ठीक है, मान ली तुम्हारी बात, बट वो नहीं आएगा। एक मिनट, तुम लोग बोल क्या रहे हो? 3k लैम्डा बाई 2, डायमेंशनल भी तो चेक कर लो। k लैम्डा बाई आर फील्ड होता है। एनीवे, क्या कर रहा है? इंटीग्रेट ही तो करना है, तो करना। All you have to do is integrate. First of all, what is the direction of field? What is the direction of the field? Your thread or your charged particle, your linear charge distribution is like this. What is the direction of the field? ऐसा रहेगा. In fact, if this is the linear charge distribution, everything is symmetric. मतलब the field, the direction over the field would be radially outwards. Correct? Okay, so you are moving from R to 2R. Effectively यही हो रहा है ना? You are moving in this direction. Okay. What is the field? What is the field? The field is equal to 2k lambda by R, where R is the distance. इससे कंफ्यूज हो रहे हो क्या? यही R ले लिया क्या? चल इसको x कर देते हैं, या इसको a कर देते हैं, 2a कर देते हैं. Field is 2k lambda by R. What is R? R is the perpendicular distance from here, na? Is it constant? Is the field constant? It's not. तो E dot dr करने के लिए मेरे को क्या करना पड़ेगा? I'll have to integrate. There is no other way. ठीक है? So what do we take? We say that at a distance r, we are going to displace it by dr. So at a distance r, this is the field. What is the direction of the field? This is positive charge, तो field किधर होगा? This will be the direction of the field. And what is the direction of the displacement? Same direction. Okay. So what is dv? dv is equal to minus of E dot dr. And what will be E dot dr in this case? E dot dr matlab E dr, because the angle between them is 0 degree. So this becomes E dr. E dr matlab 2k lambda by r multiplied by dr. That is the potential. Change in potential. And then to find delta v, what do we have to do? We have to integrate it from a to 2a. Absolutely. So this becomes minus 2k lambda, and this will become ln r. ln r में will put 2a, and then we'll put a. तो क्या मिलेगा मेरे को? ln 2a divided by a. मतलब क्या बचेगा? ln 2. So that's your answer. Minus 2k lambda minus 2 ln 2k lambda. That'll be your answer. Is that clear? कोई problem? Alright, is the integration clear? कोई problem इसमें? Okay. So what happened here? We only had field in one direction, and we were moving in that direction, so we calculated the potential. तो कोई problem नहीं था. Okay. What if field I can represent it as exi cap plus eyj cap plus ezk cap. And dr can I also represent it as dxi cap plus dyj cap plus dzk cap. Can I represent it like this? Okay, so in this case dv will be minus of E dot dr, and this is going to give me what? This is going to give me minus of ex dx plus ey dy plus ez dz. So when field is in more than one dimensions, what we can do is we can use this relationship. Matlab we are using the same relationship. In this case, what do we observe? We observe delta v is equal to, if I integrate on both sides, what do I get? Minus, and then I get ex dx ka integral, and this integral will go from where? This is going to go from x initial to x final, plus integral of ey dy, and this will go from y initial to y final, plus this is going to go from ez dz, and this is going to go from z initial to z final. And that is how we can calculate the change in potential when the field is in more than one dimension. मतलब क्या हुआ? The displacement in x direction, which field is responsible for the change in potential in x direction? Only Ex. So you can find the change in potential because of your displacement in the x direction. Then you can calculate the change in potential because of your displacement in the y direction, and then the change in potential due to your displacement in the z direction. First of all, potential is a vector quantity. I'm not saying this is the x component of potential, y component and z component of the potential. No, potential is a scalar quantity. All of them will get added into numbers. But what I'm saying is, this is the change in potential due to its displacement in the x direction. If it is moving in the x direction, which field will have an effect? Only Ex. Because Ey and Ez would be perpendicular to dx. If it is moving along dy, which field is responsible for the change in potential? Ey, and similarly for Ez. So we can calculate the potential for individual displacement because of the individual displacements in x, y and z axis respectively. Is that clear? Now you may want to attempt the previous question. What did I say? It goes from where? It goes from r, 0, 0 to 2r, r, 0. हाँ ठीक है, you try this. सोच. Your thread or your linear charge distribution is along z direction. हाँ, infinite है. Y के along भी सेम ही होगा. EY 0 कैसे हो जाएगा दोस्त? तू गलत समझ रहा है EY को. You're not getting EY. उस EY की बात नहीं कर रहे हम लोग. तो दिस इज योर थ्रेड. हम लोग किसकी बात किए थे? कंफ्यूज मत हो, हम लोग इसकी बात किए थे. ये EX होता था एंड ये EY होता था. इसकी बात हम लोग नहीं कर रहे हैं. व्हाट वी आर टॉकिंग अबाउट इज द थ्रेड इज अलोंग दिस डायरेक्शन. तो फील्ड किस डायरेक्शन में होगा? Field would be in every direction. Radially outwards, field would be in every direction. All these directions are symmetrical to this line of charge. So the field would be in all the directions. So this particle is at R and it goes from to R comma R. Matlab this is 2R comma R and this is R comma 0. It goes from this point to this point. Now you calculate the field. Sorry, the change in potential. नहीं, तुम्हारा इन्फानाइट कैसे नहीं आया? डेटा में गड़बड़ी है, रुक जाओ, नहीं तो इन्फानाइट आ जाएगा। लेट्स से ऐसा करते हैं, ऐसा करते हैं, r कॉमा r से 3r कॉमा 2r जा रहा है। इसीलिए बोले डेटा में प्रॉब्लम है। इट गोज फ्रॉम r कॉमा r टू 3r कॉमा 2r। ट्राई करो इसको। ln2 प्लस ln3 ln6। स्विच खराब होगा, इसका तो लाइट जल रहा है। डायरेक्ट हो गया होगा और क्या। अडेप्टर है रे, करंट नहीं मारेगा। हाँ, स्पार्क मार रहा था क्या? ठीक है, शांतनु को बोलना चेंज कर देंगे। ठीक है, वर यू एबल टू गेट दिस? ठीक है, दैट्स सिंपल। बस जो एक्स एक्सिस में किया वो एक्स एक्सिस और वाई एक्सिस में दोनों में करना है। ओके, सो व्हाट कैन वी राइट? Okay, so electric field, can I write it as, listen up, electric field can I write it as 2k lambda by x I cap plus 2k lambda by y j cap. Can I write that? Where x and y are the respective components. Is that correct? Okay, so what is dv? dv will then become minus of 2k lambda dx by x minus 2k lambda dy by y। डॉट कर दिया इसका डी आर के साथ। ओके, देन व्हाट विल बी डेल्टा वी? डेल्टा वी विल बी माइनस 2k लैम्डा एंड देन यू विल हैव dx by x का इंटीग्रल एंड दिस इज गोइंग टू गो फ्रॉम वेयर टू वेयर? r to 2r, r to 3r, and this would be integral of dy by y, and this integral is going to go from r to 2r। ठीक है, this gives you ln3, this gives you ln2, ln3 into 2 6, so this becomes minus 2k lambda into ln6। is that clear? ठीक है, I think we'll finish it up till here and next class we'll continue. This is the second class on electrostatics जो कि आधा चला गया। anyway, चलो।